For today's topic, we will be tackling the area of regions bounded by the polar curves. Good day everyone, I am Sharon Joy Sisulan, and today I will be discussing the area of regions bounded by the polar curves. Area of a region bounded by the polar curves. Suppose f is continuous and non-negative on the interval alpha less than equal to theta less than equal to beta, with 0 less than beta minus theta less than equal to 2 pi. The area of the region bounded by the graph of r is equals to f theta between the radical lines theta is equals to alpha and theta is equals to beta is a equals 1/2 times the interval from alpha to beta of the quantity of f of the theta squared d theta. For our first step, we have to use the polar area formula, which is the area is equals to 1/2 integral from a to b r squared d theta. Since the curve is traced once from 0 to less than equal to theta, less than equal to pi, we have area is equals to 1/2 integral 0 to pi. We have to substitute the given equation, which is the r is equals to 2 sine theta. Then, for our step 2, we have to simplify. Square the equations. It will become 1/2 integral from 0 to pi 4 sine squared theta d theta. Next is we have to factor out the constant. So it will become 2 integral from 0 to pi sine squared theta d theta. For our step 3, we have to use the identity, as you remember the trigonometric identity, which is the sine squared theta is equal to 1 minus cosine 2 theta all over 2. So now we have to substitute the identity. It will become 2 integral from 0 to pi 1 minus cosine 2 theta all over 2 d theta. And now let's simplify the expression. It will become integral from 0 to pi 1 minus cosine 2 theta d theta. Now let's do the step 4. We have to integrate. Now apply the integration rule. It will become theta minus sine 2 theta all over 2 from 0 to pi. So we have to substitute the limit, and we have the pi minus sine 2 theta all over 2 minus 0 minus sine 0 all over 2. So since we all know that the sine 2 theta is equals to 0, now our area is equals to pi. For our conclusion, therefore, the area enclosed by the curve r is equals to 2 sine theta is pi square units. For our table of values, for number 1, we have theta for our first column, and our second column r is equals to 2 sine theta. So we have to plug in the theta to our equation. So if 0, we will get the 0. If pi over 12, we will get 0.517. If pi over 6, we get 1. Pi over 4, 1.414. Pi over 3, 1.732. 5 pi over 12, 1.931. 5 pi over 2, we get 2. 7 pi over 12, we get 1.31. For 2 pi over 3, 1.732. For 3 pi over 4, 1.414. For 5 pi over 6, we get 1. 11 pi over 12, 0.517. For pi, 0. 13 pi over 12, negative 0.517. 7 pi over 6, negative 1. 5 pi over 4, negative 1.414. 4 pi over 3, negative 1.732. 17 pi over 12, negative 1.931. 3 pi over 2, negative 2. 19 pi over 12, negative 1.931. 5 pi over 3, negative 1.732. 7 pi over 4, negative 414. 11 pi over 6, negative 1. 23 pi over 2, negative 0.517. And lastly, 2 pi will get negative 0. And now let's graph our first polar curve. We have r is equals to 2 sine theta. Since we already have our table of values, we can easily plot this. So we start with plotting the points for us to easily connect them and form our graph. As you can see, I am plotting it first. Then later on, I'll be connecting those points to form the graph. As you can see, I'm starting to connect those points. Next is, I'll be shading the region. So now, I'm shading it. And this is the graph for number 1. For our step 1, we have to use the polar area formula. We have now area is equals to 1/2 integral from a to b r squared d theta. For one lobe of the rose curve, we have negative 1 pi over 4 less than equal to theta less than equal to pi over 4. Thus, we substitute r is equals to 3 cosine 2 theta. Limit for one lobe, it become 1/2 integral from negative pi over 4 to pi over 4. We plug in 3 cosine 2 theta squared d theta. For our step 2, we have to expand. Square the expression. It would become 1/2 integral from negative pi over 4 to pi over 4 become 9 cosine 2 cosine squared 2 theta d theta. And now, we have to factor the constant. It would become 9 over 2 integral from negative pi over 4 to pi over 4. Cosine squared 2 theta d theta. And for our step 3, we have to use the identity. As we all know, that trigonometric identity has cosine squared x is equals to 1 plus cosine 2x all over 2. And now we have to substitute the identity. They become 9 over 2. Integral from negative pi over 4 to pi over 4. You have the 1, plug in the 1 plus 4 theta all over 2 d theta. And now we have to simplify the expression. It will become 9 over 4. Integral from negative pi over 4 to pi over 4. It become 1 plus cosine 4 theta d theta. And for our step 4, we have to apply the integration rule. So it becomes 9 over 4 theta plus sine 4 theta all over 4 from negative pi over 4 to pi over 4. And now we have to substitute the limit, since sine pi is equals to 0. It becomes 9 over 4 times pi over 4 plus sine that sine pi is equals to 0. It becomes minus negative pi over 4 plus sine negative pi all over 4. So we have to simplify, because you all know sine pi is equals to 0. Now let's go to simplify. It will become 9 over 4 pi over 4 plus pi over 4. So we have 9 over 4 pi half. So our final answer is 9 pi all over 8. For our conclusion, therefore, the area of one lobe of the curve R3 cosine 2 theta is 9 pi over 8 square units. For our second equation, table of values, we have for first column theta, and for the second column r is equals to 3 cosine 2 theta. We have to plug in the value of r theta to our equation. So if we plug in 0 to r is equals to 3 cosine 2 theta, we'll get 3. If pi over 24, we will get 2.897. If pi over 12, we get 2.598. If pi over 8, we get 2.121. If pi over 2, we get 1.5. 5 pi over 24, we get 0.776. If pi over 4, we get 0. 7 pi over 24, we get negative 0.776. If pi over 3, we get negative 1.5. If 3 pi over 8, we get negative 2.121. If pi over 12, we get negative 2.598. If 11 pi over 24, we get negative 2.897. If 5 if pi over 2, we get negative 3. If 13 pi over 24, we get negative 2.897. If 7 pi over 12, we get negative 2.598. If 5 pi over 8, we get negative 2.121. If 2 pi over 3, we get negative 1.5. If 17 pi over 24, we get negative 0.776. If 3 pi over 4, we get 0. If 19 pi over 24, we get 0.776. If 5 pi over 6, we get 1.5. 7 pi over 8, we get 2.121. If 11 pi over 12, we get 2.598. If 23 pi over 24, we get 2.897. And if pi, we get 3. If 25 pi over 24, we get 2.97. If 13 pi over 12, we get 2.598. If 9 pi over 8, we get 2.121. If 7 pi over 6, we get 1.5. If 29 pi over 24, we get 0.776. If 5 pi over 4, we get 0. If 31 pi over 24, we get negative 0.776. If 4 pi over 3, we get negative 1.5. If 11 pi over 8, we get negative 2.121. If 17 pi over 12, we get negative 2.598. If 35 pi over 24, we get negative 2.897. If 3 pi over 2, we get negative 3.0. If 37 pi over 24, we get negative 2.897. If 19 pi over 12, we get negative 2.598. If 13 pi over 8, we get negative 2.121. If 5 pi over 3, we get negative 1.5. If 41 pi over 24, we get negative 0.776. If 7 pi over 4, we get negative 0. If 43 pi over 24, we get 0.776. If 11 pi over 6, we got 1.5. 15 pi over 8, we get 2.121. 23 pi over 12, we get 2.598. 47 pi over 24, we get 2.897. And for lastly, we get 2 pi, we get 3. So now, let's proceed to our graph number 2. Since we already done our table of values earlier, we'll now proceed to plotting the points. So as you can see there, I'm plotting the points so that I will be easily connecting those points to form the graph. And now, I'll be connecting those points to form a graph. And now, let's shade the one region or one leaf of the rose. That's it for graph number 2. For our step 1, we have to find the points of intersection. We need to determine the interval of theta where the outside the circle set the two equations equals to each other. So 3 plus 1 cosine theta is equals to 2. You have to set equation equal. Then isolate the cosine. 2 cosine theta is equals to 1. So divide both sides. We get theta cosine theta is equal to negative 1 over 2. The reference angle is pi over 3. Since cosine is negative in the second and the third quadrants, for first interval we have pi minus pi over 3. We will get 2 pi over 3. For our second, pi plus pi over 3, we will get 4 pi over 3. For step 2, set up the integral. Theta is equal to 2 pi over 3 and 4 pi over 3. The area of the two polar curve is area is equals to integral from A to B, 1/2 r squared outer minus r squared inner d theta. Using the symmetry, doubling the integral from 0 to 2 pi over 3, we'll get 2 integral 0 to 2 pi over 3. In a way, we have to substitute plus the symmetry. 1/2 times 3 plus 2 cosine theta squared minus 2 squared d theta. Next is we have to simplify the constants. So we will get integral from 0 to 2 pi over 3. 9 plus 12 cosine theta plus 4 cosine squared theta minus 4 d theta. Now, we combine like terms. We will get area is equals to integral from 0 to 2 pi over 3. 5 plus 12 cosine theta plus 4 cosine squared theta d theta. Now, use the trigonometric identities, which is the cosine squared theta is equals to 1 plus cosine 2 theta all over 2. So now we have integral of from 0 to 2 pi over 3. Now let's substitute the identity. You will get 5 plus 12 cosine 2 theta plus 4 times 1 plus cosine 2 theta over 2 d theta. Now, simplify the equation. We will get integral from 0 to 2 pi over 3. 5 plus 12 cosine theta plus 2 cosine 2 theta d theta. Now, we get integral of from 0 to 2 pi over 3. 7 plus 12 cosine theta plus 2 theta d theta. Now, let's integrate 7 theta plus 12 sine theta plus 2 sine 2 theta all over 2 from 0 to 2 pi over 3. We will get 7 theta plus 12 sine theta plus sine 2 theta 0 from 0 to 2 pi over 3. And now, let's evaluate. So, 7 times 2 pi over 3 is equals to 11 pi over 3. 12 sine times 2 pi over 3 is equals to 12 square root of 3 over 2 is equals to 6 square root of 3. So, sine 4 theta all over 3 is equals to negative square root of 3 all over 2. Subtract the lower limit 0. So, 7 times 0 plus 12 sine times 0 plus sine times 0 is equals to 0. Area is equals to 14 pi over 3 plus 6 square root of 3 minus square root of 3 over 2. So we will get area is equals to 14 pi over 3 plus 11 square root of 3 over 2, our final answer. In numerical answer, we will get area is equals to 14.661 plus 9.526, so 24.187 square unit. For the conclusion, therefore, the area inside the limacon R is equals to 3 plus 2 cosine theta, and outside the circle R is equals to 2 is 14 pi over 3 plus 11 square root of 3 all over 2 square unit. So for our last table of values, for number 3, we will have our first column for theta, second column for R is equals to 2, and for our third column, we have R is equals to 3 plus 2 cosine theta. So if we plug in the value of our theta to our second equation, which is the R is equals to 3 plus 2 cosine theta, we will get, if 0, we will get 5. If pi over 12, we will get 4.319. If pi over 6, we will get 4.732. If pi over 4, we get 4.414. If pi over 3, we get 4. If 5 pi over 12, we got 3.517. If pi over 2, we got 3. And if 7 pi over 12, we got 2.482. If 2 pi over 3, we get 2. 3 pi over 4, we get 1.585. If 5 pi over 6, we get 1.267. If 11 pi over 12, we get 1.068. If pi, we get 1. If 13 pi over 12, we get 1.068. If 7 pi over 6, we get 1.267. If 5 pi over 4, we get 1.585. If 4 pi over 3, we get 2. If 7 pi over 12, we get 2.482. If 3 pi over 2, we get 3. If 19 pi over 12, we get 3.517. If 5 pi over 3, we get 4. If 7 pi over 4, we get 4.141. If 11 pi over 6, we get 4.732. If 23 pi over 12, we get 4.932. If 2 pi, we get 5. For our last graph number 3, since we already have our table of values earlier, now we can easily plot those points. Then after that, we connect those. So as you can see of what I'm doing there, is that I'm plotting those points for me to easily connect those later. And now I'm connecting those points to form the graph. Now let's go to our next equation, which is R is equals to. So as you can see, the graph for R is equals to 3 plus 2 cosine theta, and R is equals to 2. And now I'm shading the region, as you can see. So this is our graph number 3. I hope you learned something, and thank you for watching.